is now look at this situation. Why does your body move forward when you stop? That's the question that we want to answer right there. And I think this is another really huge misconception. So this is a perfect time to answer this question. Now, suppose you're driving down the highway and you suddenly stop, right? So let's set this up. So suppose you're driving along the highway and suddenly stop. You feel your body moving forward. And the question is, why does this happen? Okay, why does this happen? So let's look at this thing. Let's try to draw this in more detail to see what actually happens here. So let's say that you're driving your car at 50 miles an hour. So again, maybe we should say, suppose the car is moving at 50 miles an hour. So what does that mean? Well, if I think about it, if I look at my picture here, it means this. And what it means here is that as I'm driving 50 miles an hour, what I'm going to see here is that I have my car, of course. I should actually put a seat in here with the headrest. So when I look at that little person in there, what I'm seeing here is that I'm seeing this. I have the head, I have the body, like this. So if I look at the car, then I have this scenario. And so what you're really seeing here is that you're seeing this here. What you're seeing here is that your body is moving at the same speed as the car. So what I'm saying here is this, is that both the car and your body move at 50 miles an hour. And that's what I'm showing you right there. So what does this say here? What we're going to do now is that we're going to do the following thing. Here, you're going to slam on the brakes. So now what I got to do here is that I got to think about what do the laws of physics say. So when I look at the person here, so if I look at that person, what it says here is that Newton's first law says objects moving at 50 miles an hour, constant velocity, will continue moving 50 miles an hour forever. right? They're going to continue moving at constant velocity forever. But when you hit the brakes, it's the car that slows down, not your body. So when I look at this thing, I could now come over here and do the exact same thing. So what I'm going to do here is that I'm going to copy this. I'm going to bring it over here. And let's say here that I really hit the brakes hard. And that now this time, my car is not moving 50 miles an hour anymore. It's moving 20 miles an hour. So what happens then? Let's go look at that. So what's happening to the body? Your body moves forward because it is moving faster than the car. Right? Right here, we see here is that the car is moving slower. But it's the car that experiences the brake, not your body. So the misconception here is this. Here's the misconception. People will say that the car throws you forwards. Guess what? That's wrong. The car doesn't throw you forwards. You're now moving faster than the car, so therefore you naturally slide forward. And the same thing happens when you're speeding up. If you were to look at the situation when you're speeding up, why does your body move backwards when you speed up? Because the car is now moving faster than your body. So then the seat has to push harder on you to speed you up to the same speed. That's why your body moves backwards. Another way of looking at this, we could say the exact same thing. So here we ask the question, why does your body move forward when you stop? Now I could do the exact same thing and ask this question. Maybe I should do this as a third question, but it's really the same situation. Why do you, not your, you move, not forwards, you move, how do I say this? Towards the door of your car while turning. Okay, why does it move towards the door? And the classic example is the fish hook. So what I'm going to do here is I'm going to talk about the fish hook. The fish hook turn in Santa Cruz. So what do I know about the fish hook? So what I'm going to do here is that I'm going to give you a top view. Okay, that's wrong. Top view of the car. So what I'm seeing here is that, let's say that this is the fish hook. So when you get on the fish hook, it makes a turn like this here. So let's look at this here. So as your car is coming in, let's say that this is the car, And then this is you. So this guy right here is the person in the car. Okay, it's the person in the car. And what you're seeing here, this is the direction of motion of the car. So if I look at this line right here, what this tells me here is that this guy right here is the line of constant velocity. So according to Newton's first law, what does it say? So let's answer this question. So I know that Newton's first law states that your body wants to move in a straight line in a straight line. It wants to stay moving at constant velocity. But what happens though? To stay on the road, the car changes direction. So the car now has physically changed. So the car now has to look like this. So the car is moving like that. So this here is the motion of the car now, right? This is the car direction. But that's not your direction. Newton's first law says you're continuing to move in this straight line way. So what we say then is that your body continues to move in a straight line. Because of Newton's first law. Okay, because of Newton's first law. Now what I have here is I have a different video that I want to show you. And believe it is or not, I did this video probably 30 years ago. So this is an old video. So what I'm going to do here is that this is what you're going to see here. Let me set this up. So my picture of the video starts off like this. So what I did here is that I took a 5-gallon lid and then I cut a piece off of it. And what I'm going to do here is I'm going to take that ball bearing and I'm going to roll it along the edge. So the question is, what is that ball bearing going to do? Is it going to move this way? Let's call it A, along the track. Is it going to move B, straight? Or is it going to move C, outwards like that? Now, if you ever have played on a merry-go-round, then the question is, imagine that you're on a merry-go-round. Oh, no, I got a better question. Imagine that you're driving the fish hook, okay? You're driving the fish hook and you suddenly let go of the steering wheel. Which way are you going to go? Right? That's the question that I'm really asking. So here's my fish hook, right? Here's the fish hook. Okay, there's the fish hook. You let go of the steering wheel. is your body going to do this here? Is it going to go that way? X? This way? Y? Or is it going to take the path of Z? Which direction will your body go? And the answer is, what was the direction that you were traveling initially? You were traveling straight. So if you were traveling straight, then after you let go of the steering wheel, according to Newton's first law, you would not go towards the door and fly off in the X direction. You would continue to move in a straight line. And now look at this video here that I have set up for you. So if I now play this video for you, check it out. You see that it continues to move in that straight line, right? It continues to move in that straight line, which is pretty spectacular when you think about it. So what I'm going to do here is that I want to come in and I want to share an image, that image again. That looks like this. So what you're seeing here is that what actually happens is this thing right here. Which direction is it going to go? It's going to follow the path of B. It continues to go straight, which is shocking when you think about that, right? That's really shocking. Okay. I am now done with chapter 2. So what this means here is that